So far with the law of sines, we have looked at cases that look like angle, side angle, or angle, angle, side. Law of sines can also be extended to side, side, angle, but we need to be extremely careful because this produces what we call an ambiguous case. And what I mean by an ambiguous case is that you could end up with 0 triangles, 1 triangle, or 2 triangles. So you're going to have to figure out how many triangles are you actually dealing with before you can actually solve the triangle. And in this video, I'm just going to show you how do we determine the number of triangles. And then I'll split the examples up into other videos. Okay, so there's going to be this big giant chart here, and it's split up into 2 categories. One category is where they give you 2 sides and an angle, and the angle is acute. The other is they give you 2 sides and an angle that is either right or obtuse. I'm actually going to start with the right or obtuse side. Keep in mind that I would kind of jot down this chart as best as you can. You don't really need the pictures, but I'll show you how do we come up with each one of these scenarios. So starting with angle A is either a right or obtuse triangle. I'm going to go off to another slide. So here's a scenario. I have a side length, another side length, and an angle measure. Notice how the angle is not between the 2 sides. That's how they name it side-side angle. So this angle is fixed at 120 degrees. This side length is fixed at 3, and this side length up here is fixed at 1. This bottom line down here, this would represent the 3rd side of my triangle. However, this side would hit it down at the bottom. So my scenario is I have an angle measure A. This 1 would be considered side length A. And then this over here is going to be side length B, because off in the corner over here somewhere would be angle B. Notice how A compares to B right now. A is less than B. My goal is to try and get this line extended so that it reaches the bottom over here to form a triangle. Well, when A is less than B, that side length, even though it rotates freely up there, because this angle measure is not fixed, it never hits this bottom line down here. So therefore, there is no triangle within this. So that's your first scenario. If A is less than B, you do not have a triangle. Your other scenario is where A is bigger than B. So now I'm going to extend this side length a little bit. And I'm going to make this side length become something like 4.2. So now notice how my side length A is bigger than side length B. This side still rotates freely, but notice this time I can actually make it hit that bottom line down there and can form a triangle. There's my triangle, and you can see that it produces one solution. Even though I can continually rotate this, I'm not going to be able to make that triangle, make another triangle out of this. So I'm only going to have one solution out of this, which makes up your bottom scenario. If A is bigger than B, you get one solution. So there's the case for when A is, when the angle given to me is either a right angle or an obtuse angle. Next, we're going to go to the idea of angle A being acute. I'm going to go back to my picture, and now I'm going to make an acute angle. I'm going to back this side length up just a little bit. Let's deal with an angle measure of, say, 52 degrees. When we go back to the chart, you can see that I'm comparing a side length A, that's the same side length. I have a side length B in some cases, and I have this H. H is considered the height of the triangle. So a lot of the times you're actually going to have to find the height out of here. So that's what I'm going to do first. I'm going to show the height of the triangle. And in this scenario, this height of the triangle would be 2.3. Right? And our first scenario is if I compare my side length A with the height. This height would be the shortest distance from this point C all the way down here to the bottom. Well, if A is actually less than H, I can spin this as much as I want. It never reaches the bottom, so therefore there would be no triangle. Right? That would be your first scenario. If A is less than H, your height, you do not have a triangle. If A does equal H then, so if I make that side length 2.3 exactly, well then it definitely should form a triangle that is just long enough to make that triangle in there. So if that side length A is equal to the altitude, you end up with one triangle. You can spin it as much as you like, but you're only going to hit one triangle. That's your next one. That one actually forms a right triangle. Your next one, right, would be something that looks like this. Let's do 2.8 in this case. So looking at 2.8 and comparing all three of these side lengths, notice that my side length A, because it's across from the 52, is bigger than my height, but is less than my other side length B. I can spin this side length. That would be a triangle right there. That would be one. But I can also make another triangle out of this. If I keep spinning this thing, come all the way over to the other side, it's a small triangle, but it's there. There's your other triangle that's formed. So in this case, you actually end up with two triangles that have a side length of 2.8, a side length of 3, and an angle measure of 52. One being right here. I'm going to get rid of the height right now. One being right there, and your other triangle being way over here. Actually forms a little sliver, obtuse triangle. So that's your other scenario. That's one more, where H is less than the side length A, but A is also less than the side length of B. Oops, wrong spot. That is this one. You'd end up with two solutions. Your last one is very similar to an obtuse triangle. Now, if A is actually bigger than B, so in this case I have a side length maybe of 3.3, so A is bigger than B, we're going to end up with one triangle. There'd be my first triangle. I could spin this thing all the way over if I want, but notice how it crosses over. I'm not going to form another triangle out of it. So I just end up with one triangle if A is bigger than B. And that's your last one. And that's how you're going to have to determine whether you have one triangle, two triangles, or no triangles.